Hello, and welcome to another episode of Hacking with Friends. Today we have our production gremlin Michael here.
Security researcher.
Yes, sorry. And my name is Kody Kinsey. I'm a security researcher with Varonis. And today we're going to do something a little bit unusual. We're not going to go over a tool to actually hack something. Instead, we're going to go over a tool to detect hackers and actually start to be able to detect when someone's doing some tricky Wi-Fi hacking in our immediate vicinity.
Sounds fascinating.
Yeah, so this is only possible thanks to another one of our guests, Stefan Kremser. This is a spin-off of one of his projects that's called the Deauth Detector. And in order for that to make sense, we have to explain a little bit about the way Wi-Fi works and a little bit about the way this vulnerability against current Wi-Fi works and why it's such a big deal. So, Michael, do you know what a Deauth attack is?
Yeah, it's like one of the most basic script kiddie attacks ever that has been around for like decades now.
Decade. Yeah.
A decade at least.
Yeah.
Basically, there are these things called management packets, which the Wi-Fi access point uses to control devices connected to it. And one of those specific frames is a de-authentication frame. So basically that's change your password, do anything like that, and you're like, get off my network. That's this packet. And essentially...
So just to clarify, if the router is to change its password, you're leaving the area, or for some other reason it decides that you're not on that network anymore, then this is the packet that it sends you to terminate the connection.
Right. And so that's just the de-authentication packet. And why we can take advantage of this is it's unencrypted and unauthenticated, which means that I can just say, oh, yes, why, sure, I am the access point you think I am. Trust me. And get off my network. So essentially what you're doing during a Deauth attack is you're just spamming a ton of packets that are like, yes, I am this network. Now get off my network.
Yeah, essentially, yes. So, all right, that's a pretty good description. Basically, the way that Wi-Fi works is there are some packets that are encrypted, and you need the password to that network in order to listen in on that conversation or participate in on that conversation. But there are also packets that are not encrypted. And in the current standard of Wi-Fi, which is WPA2, there are some packets called management frames, which are not encrypted, but are super important for managing the way that networks work. Now, can you think of a reason why they might leave management packets or management frames unencrypted?
I'm sure that, like, from a computer science or like in electrical engineering standpoint, that there's something like they need to be efficient, or like there's potential for them to be misinterpreted if they're encrypted or something.
Well, here's a question. How do you join an encrypted network if all the packets are encrypted?
Right, but
how does your computer know, for one, the capabilities of that network and whether or not it's even worth it to try to connect to it? And then how do they know, anything about it?
Well, that makes sense.
So like if some packets aren't unencrypted, then like it's not possible to join the network.
Right.
So for example, authentication packets, before you negotiate a secret key with that network, you need to be able to see like what you're doing and see the key presented to you, basically in plain text. So you guys can agree on installing an encryption key, and then boom, you guys can speak encryptedly. But encrypted.
And for like broadcast frames, like, hey, I'm a network. Here, join me.
Just for letting anyone around you know that there's a network here, the average Wi-Fi network will put out hundreds of, or at least 100 or so different beacon frames per second that say...
that many?
Well, no, sorry, per minute.
I was going to say, that's a lot.
Sorry, per minute. Per minute that advertise the capabilities, name, and other qualities of that Wi-Fi network to make you aware that it's there. So when you press the button on your phone that populates all the nearby Wi-Fi networks, that's really what you're seeing. You're just scanning for those packets. And those are unencrypted. But there's other more important unencrypted packets that we as hackers can abuse. Now, some of those are probe frames. That's where a device like my laptop, for example, might be calling out for a network it's connected to recently. That's also unencrypted. It might be something like an authentication frame, which is the first step of a device attempting to connect to a network. Or it can be a de-authentication frame or a disassociation frame. Now, these two types of packets are used to control basically when a connection is terminated. So if you are leaving one area and going to another area and you're going out of range of a network, then you might get a disassociation packet. If you are basically getting kicked off the network because it's changed its password or something like that, then you might get a deauthentication packet. And what happens is if a hacker wants to use these packets maliciously, they can basically forge a message. And in the from address, they put the MAC address of the router. In the to address, they put the MAC address of the device they want to kick off the network. And then they send the packet. And to everybody on the network, it looks like, the router just told this device to get off the network. So the device just obeys. And if the hacker keeps this up and keeps sending a stream of continuous packets, it becomes a denial of service attack. And that means that the device just cannot connect to the network. Every time it attempts to, it gets hit with a seemingly legitimate request from the router it has to obey that says disconnect from the network. So it's really, really interesting how simple this attack is. Both of these packets do roughly the same thing, and we can abuse them in roughly the same way. But being able to detect this attack is not so simple, because the average person probably doesn't have training in Wireshark or really know how to tell if someone
probably even understand what's going on.
What I just said. Yeah, exactly. Yeah, so like if this is all news to you, then you should be aware that there's this really big flaw in Wi-Fi that enables anybody to kick any device off of Wi-Fi. So today we're going to go over how to discover if someone is doing this and how to basically demonstrate when we detect it. And that's why we've built this extremely fancy device right here. As you can see, very high quality, very fancy. So this is a breadboard with a microcontroller on it. And what we've done is we've set up, I believe the red packets are disassociation packets and the green ones are deauthentication packets. It might be flipped. I'll have to check the code. But basically these LEDs will light up anytime someone is doing an attack. And we're going to demonstrate this today by actually doing an attack and watching them hopefully light up. So,
so just to be clear, so essentially what this device is doing is it monitors the Wi-Fi networks. And since these are unencrypted and unauthenticated, that means that anything can passively listen to them and read them fully. So it's able to just passively listen for these, even if it's going to a network that it's not connected to.
Right. So basically what the code that we're working with today is doing is it's listening for these two types of special packets that aren't used very often. And if we see that suddenly there's a large amount of these packets flying around, it's going to turn on these lights. But we're also going to add some other elements to it. We can increase or decrease the sensitivity. So if it's going off just because something's deauthing something nearby, then we can decrease the sensitivity. We can decrease the channels that it scans on. So instead of scanning on all channels, you can just scan on the channel that your network is operating on. So there's other things we can build into this that allow it to basically discriminate and basically say, oh, well, if it's not this particular network or if it's not this particular channel, then I'm going to ignore it.
Yeah, it would seem pretty normal, I imagine, to get like a dissociation packet every once in a while, just from normal behavior. And but what we're looking for mainly
corporate equipment will do this too, because corporate networks are aggressive and they'll try to kick off devices that aren't supposed to be there. And sometimes they'll fight with like other networks. So at the perimeter of people's networks, you can have like basically like deauthentication packets like flying between the two, which can set this off.
Oh, it's interesting that you actually note that, because that's something when we were talking about this live stream before, it made me think of a enterprise grade access point that I had looked at in the past, the dream Wi-Fi I would want. And one of its selling points is that like out of band Wi-Fi management security network thing. So essentially it's doing the same thing as this. It has a dedicated security radio that is purely listening for packets.
Interesting. So you just have like a like an intrusion. Please don't. I don't want to do a no.
Okay. Sorry. And so the one I was talking about is the Ubiquiti Base Station XG, but like dedicated security radio with persistent threat management.
Wait, you're on my screen.
Wait, no, it's one.
There you go.
Okay, yeah, sorry. Dedicated security radio with persistent threat management. To me, that's just fancy speak for basically this.
Yeah, exactly. Well, it probably is able to detect other types of automated tools. So what I like about this is it's really dead simple, and there's a lot of dedicated tools like BSideNG or something that are going to be firing off deauthentication packets left and right. You also might use a tool like MDK4 and also AeroPlay NG. You can do a lot of different things with that to just kick devices off of a network. All of those will trip this because at its fundamental level, we're using, let's say we're trying to capture a handshake and we need to just kick a device off a network for a second. We're still using the same types of packets to do this. So we should be triggering this alert no matter what. And I'll go into how that actually works in just a second.
Well, what's fascinating to me about this, though, is this is like a $2 microcontroller. But if I were to buy an access point like this, $1,500.
Oh, yeah.
Like, obviously, this has a lot more capabilities than just the security aspect. But if I wanted something with the security aspect like this, I would have to pay a boatload of money for it. And, like, you know, especially for, like, working from home, if you're concerned about your Wi-Fi security or anything like that, this is a fun, little, easy Wi-Fi project to do on the weekend. Learn a little microcontroller, learn a little Arduino sketch, and then have it on your wall. I imagine, like, we can get into this later, but you could probably upgrade it to like do like some sort of push notification or something, like if there's Deauth authentication.
Yeah, you can do that. So basically what we're going to do today is work with this $2 microcontroller that is really, really cheap and programmable in Arduino IDE. And because this is a microcontroller, which is the ESP8266, that is built for Wi-Fi modularity, our friend Stefan has hacked this to make it so it can do a lot of things that it might not have been intended to do. And that's what we're going to do today. So can you switch to the zoom in camera?
Yeah.
All right. So
fancy zoom in.
Yeah. So here, we're taking a look at this very up close. But you can see this is our ESP8266. It's mounted on a D1 Mini.
Yeah, probably the most popular microcontroller for these sorts of projects.
Absolutely, yeah. So on this, there's lots of different pins that are broken out, and we are currently connected to, you can sort of see there.
Oh, yeah. So
we're currently connected to pins like D5 and D7. I'll go back and see in the code. Yeah. You can see there's what's called a silk screen that has all the pins on it that lets us know where we're connecting to. So basically what we're doing today is we're connecting some LEDs to these, and we're going to use the LEDs to show us when we're being deauthed. So we have some LEDs plugged in here. We've connected pins, I think D5 and D7. You see these red LEDs versus these green LEDs over here. Yeah. And we've wired this up so that basically these rows of LEDs will turn on as soon as we start detecting packets. So these are all in a row and on a breadboard. This allows us to just kind of put everything together and make it really simple to throw together an electronics prototype like this.
So an important note here, I just remembered with the ESP8266, that is 2.4 gigahertz only, correct?
Yes. So all of these microcontrollers right now are going to be 2.4 gigahertz. They are not going to support 5 gigahertz. So if you're interested in something that's dual band, unfortunately, there's not an option, as far as I'm aware of, that can do this on a microcontroller.
But Deauth packets are still a thing with 5 gigahertz?
Oh, definitely, yeah. You can attack those. You just need a wireless network adapter.
Okay, so this will provide some level of protection, but it's not it's got its flaws.
Well, I mean, for how cheap it is, I'm
for $2, right? Yeah.
All right, so here I'm just gonna leave that here for now. Let's go ahead and switch over to my screen, and hopefully I'll put this somewhere visible, in my frame maybe.
The correct screen this time.
Yes. So I'm gonna. Where can I? I don't know. We'll just have it between us. Oh no, you can see it right here. Okay, cool. So here on my little corner right there, if we get this to light up red or green, then we know that we have a success. And hopefully it shouldn't light up until we want it to. Okay, so right now I'm looking at a Wireshark Capture. And this is me attacking just the absolute crap out of some network. And it's my home network. And what you're seeing here is I've flagged, or basically added a filter in Wireshark to deauthentication and disassociation packets. So it looks like Halloween every time I start attacking something. So you can see that the way Stefan's deauther works is it does not mess around. It fires off both deauthentication and disassociation packets, and it does it a lot. So that is pretty impressive. And what we can do here is we can use this behavior to basically write a filter that allows us to detect these sorts of packets. So if I click on this, I can just start digging around in the packet and looking at information. And I already have it open. Let me close it.
Just a curious thought. Like, I know it would probably be against the Wi-Fi standard, but I wonder if you could make like your Wi-Fi projects just like listen for Deauth packets for like a second when it receives one, and if it receives like 50, then it just ignores them.
Yeah, you can do that. That's doable. But but you need to go into the standard to tell it to like behave differently than the way it's like.
That's what I'm
wired to,
saying is it would be completely against standard.
Right. Okay, so here, if we dig around in the packet, we can see that there's a bunch of information about the receiver, destination, transmitter, source. The receiver and the destination are frequently the same as are the transmitter and source, but not always. But in this case, we're forging it. So we had another little ESP8266 board forging the MAC address of the router here and sending it to my computer, I believe. So if we see...
Right. So you need to see like the access point at least once, so that way you know what to emulate.
Yes. Okay, so here we can see the relevant bits. So we can see there's a certain designator here for disassociation packets. And I'm going to close this. I'm going to right mouse click here, apply as filter, selected. And then we can see that we're looking for the wireless subtype is 0x000A. And this gives us basically a filter that only shows disassociation packets. And there's another filter we can use to find deauthentication packets. So we can use a filter like this to identify either. And that's basically what we're going to do in our Arduino code.
Is there a reason you might use one over the other? Like disassociation?
Yes, different types of packets affect different devices differently, and it's because Wi-Fi is not a monolith. Each manufacturer will choose to implement the Wi-Fi standard to its own kind of degree of seriousness. So there will be weird little quirks in the way that different devices implement Wi-Fi. It's just not that unified. Gotcha. And you'll find that some devices will react quite strongly to deauthentication, and others will react much better to a combination of deauthentication and disassociation. Others will just react wholesale to disassociation. You can just use that. And it's really kind of random.
Yeah, and there's no like problem like with the deauth and just throw both kinds of packets, I guess.
Right. So I'm going to go ahead and go to Arduino, and I'm going to take a look at this code that we're working with today. And this is a fork of the code that that Stefan wrote, and I forked this. This is not what I want. God, I hope this is. No, I'm not going to risk it. I'm just going to stay here. Okay, so we're going to go to GitHub. Yeah. And then on GitHub, we're going to go, oh my gosh, no, I don't want to confirm my account. Just regular GitHub, please. None of that. None of this. I don't care about that. Okay, well, GitHub is being awful. Are you kidding me?
Denied.
It's just, yeah, okay, hold on. I want to do the Deauth Detector. Oh, I already searched for it. Okay, cool.
Googling yourself.
Shut up. All right. So is this here? Finally, I don't know why it's right. Okay. So if I go to repositories, we should be able to find the Deauth Detector. Oh my gosh! Finally, that was ridiculous. Okay. So here we have a lot of
it's been a while,
documentation for this project. And really the only thing I did here was I forked it, and then I added the ability to also detect disassociation packets, because originally this only detected one type. So you can go ahead and grab the code here on github.com/skidcar/Deauth Detector.
Yeah.
And if you go into the Deauth Detector INO, this is where the kind of guts of the program are. So let's go over to Arduino, and we'll take a look at this, pretty much the exact same program.
Yeah, I was going to say, if you're looking for your $1 million IoT project idea, I think adding this to like an IoT device and having like an in-house like Wi-Fi hacking detector would definitely have some interest there.
I guess maybe. I think it's
just, it
would go off. I think it would go off like by accident all the time.
Yeah.
I had one wired in my house, and it would just go off, and like it would freak me out and make me more paranoid than it actually did like help me.
Yeah.
So like I don't know, but okay. So here are the settings, and Stefan has broken this out to be really nice and easy to change. So here we can see the channel that we're going to set it to start on. And that this really doesn't matter if we have channel hopping set to true, because then it'll go through all channels. But if we want to keep it on one channel, then we can select it here. So in this case, I'm going to set it on channel 6, because that's where I know my target access point is.
And that's like the most popular, like 1 and 6, right?
1, 6, and 11.
Yeah.
And then here we're going to set the channel hopping to false. So that means that it's going to stay on channel 6. Now, if we set this to true, then the next couple things actually matter, or the next one actually matters. This is where we set the maximum channel. And in the United States, we only go to 11. But if you're in the European Union, you go up to 13. And if you're in Japan, you go up to 14. So we shouldn't be scanning on those channels because it interferes with like airport radar here and you can get in trouble. So in the United States, you should have this set to 11 because really also there's no real benefit to like being on channel 14. It just wastes the time of the scan. So next up, we have the LED pin. And originally this was set to, I just leave it set to 2 on the D1 Mini. Originally, I was trying to change this, and I realized later in the code that's when it actually selects which pin is used to like light up the lights, which was very annoying. I forgot about that. And then you can also set to inverted. So if you want to make it so that the lights start off on, and then when someone attacks you, they turn off, you can do that too if you want. Or if you just wire it backward, if you wire it so that they're off and then you want them to turn on, it'll invert it. So here is where you can change the sensitivity. And this is basically where we would decide when an attack has occurred. So we can say, do we want a packet rate of 3 per minute to be an attack, or do we want it to be more than that? We can kind of fine tune it here to prevent too many false positives that would eventually cause us to just ignore this.
Yeah, and that's where I was thinking, I think 3 is probably good, but
yeah. And then why is there a space here? So here you can see we can adjust the scan time. And the scan time is basically where we're able to determine how much time we spend on each channel if we are surfing between them.
Is that milliseconds or?
Yeah, it's in milliseconds. So that's kind of the final little piece of control we have here, where we can scan around and do all the stuff and be able to very specifically say, hey, I want to scan this entire range of channels, or hey, I want to scan just on this one channel. And you can adjust the amount of time it spends on each channel if it's really maybe not being as sensitive as you want it to be.
Gotcha.
All right, so down as we scroll through here, we can see I added a a variable for disassociation. As we go down, Stefan does a bunch of magic here with reading the packet buffer and all this stuff. And then I just added this little thing here, which is if buffer 12, this is just the element in this buffer, equals 0xA0, then it is I believe it's a disassociation. And if the buffer equals 0xC0, then it's a deauthentication. So if you go back over to Wireshark, we can see that this is a disassociation. So 0x000A. So over here we see 0xa. So there's something in common over here. So these are derived from each other. Basically, this is something that allows us to designate when we see a packet if it is the disassociation or if it is the deauthentication. So what I did here is I basically added a score. So I said, all right, let's keep a running tally. If we see a disassociation packet, then add 500 to the score of disassociation packets.
500.
You'll see. Okay. If we see a deauthentication, add 500 to the score. Otherwise, if deauthentication is greater than 1, subtract 1. And if the disassociation is greater than 1, subtract 1. Now, the reason we do this is we can't, the ESP8266 is very limited on resources. So we can't do multiple things at the same time. It'll crash the stupid little clock inside of it. Okay. So in order to do that, we need to do things like keep track of variables and stuff in kind of sneaky ways. And what I'm doing here is basically creating a cooldown. So if I detect something over a certain threshold, then it creates a score that slowly cools down every second that it doesn't, or every cycle that it doesn't detect it. So we have a bunch of stuff that enables the serial mode, which allows us to see whether or not this is actually working. We'll check that out in just a second. And then it goes ahead and does the, it automatically disconnects from the station. I found that if you don't do this, sometimes it'll get stuck. We set the pins to output, and that means we take these pins that we've wired the LEDs to, and we set them to be in output mode, so we're not reading a sensor. We're actually sending some current through them. And then we print something as soon as we start up. So here we take a look at the current time, and this is just a little time trick that we use to be able to keep track of, basically without a clock, like how long things have gone. If the current time minus the previous time is equal to or less than the amount of time we've set for the scan time, then previous time equals current time.
So this isn't going to scan indefinitely. Or wait,
right,
no,
so
it doesn't
scan.
channel time thing.
Exactly.
Yeah, okay.
So when we set the channel time, say at 500 milliseconds, it'll basically start taking this at a certain time and then keep checking to see if the amount of time that's passed is equal to 500 milliseconds. And then as soon as it is, it'll run this line of code.
Okay, gotcha.
So if we have a Deauth score that is more than 1, then we turn on the light. If we have a disassociated score that's more than 1, then we turn on the light.
Okay, so that's what that score is for, is how long you're leaving the light on.
Basically, yes.
Gotcha.
So because of the way this works, it's really
That's
basically
a little roundabout.
It's a very stupid thing. So in this code, basically, if I turn on the light, if I wanted to delay for a certain amount of time and then turn off the light, this code would crash. And the reason is the Wi-Fi radio needs to use the clock. And if you basically if you halt execution for like 10 seconds, the code freaks out and it dies. So it's very hard to put delays into code like this. So what we did here is we can basically adjust the value of every time we have a positive detection, we give it a score, and then just naturally as it runs through cycles, it's going to like leave the light on for a certain amount of time. Very ghetto. This is ghetto
I was gonna
code.
say, is there like a defined amount of time for each cycle, or is it like variable?
No, it's as fast as this microcontroller goes.
Okay, so 500 is kind of an ambiguous amount of time.
No, 500 milliseconds is not connected.
Okay.
Is not connected to the LEDs. 500 milliseconds is how long between each scan or between each.
Yeah,
channel.
I was thinking the 500 score though.
Right. Oh, right.
Because you're counting down from that, but that's iterating each cycle.
So in 500 cycles is basically what we're saying.
So you're not saying 500 milliseconds, you're saying 500
loops.
cycle. Yeah.
In 500 loops, basically,
I guess
turn off the LED.
The loop time itself won't change because the code's not changing, I guess.
Yeah, so it's like a very sneaky ghetto way of getting around the fact that it's hard to call delays in Arduino when you're working with the wireless radio. You're welcome, guys.
Yeah, that's very sketchy. But clever workaround, but still very sketch.
All right, so we go ahead and flash this over. In this case, I'm going to be flashing this over to the ESP8266.
Yeah. It makes me wonder how many products out there are running stupid solutions like that just work.
Yeah, so I'm going to select, I hope it's this one. Let's select this one. So I'm going to press Command-Shift-M, and that should open the serial number. Okay, and that's the other one. So I'm going to connect to this one instead. I hope that's the right one.
So right now, what are you doing?
So right now, I'm connecting via serial to these ESPs that are plugged in, trying to find the one that's not busy.
And they already have, so they all come with like a serial interface. You don't have to have any special hardware. You just plug it in with that.
Hey, there we go. What's this? What's all this nonsense?
Some gibber?
Yeah, let's see. So I'm just going to reset and see if anything happens. Boop. Oh yeah, see, it got all angry for a second.
Yeah.
All right, so here we have a bunch of gibberish, but basically this is the serial communication back from this device. And we can set the baud rate and all that other stuff in the code. Right now, for some reason, it's giving us a bunch of question marks, which is confusing. But I'm going to assume it's running just fine because it is not crashing. So usually what we do here in order to scan, and actually I'm going to unplug the attack device. And this is the attack device. This is the evil.
Another D1 Mini.
Yeah, another D1 Mini is our evil device right now. So let's go ahead and flash this. Now I won't flash the wrong device. So here I'm going to select what's hopefully now the correct device. And we should be able to flash this over pretty quickly and confirm over serial that it is running. All right, so that looks right. We'll press upload. And again, this is pretty cool. You can, in the code, wait, scan time was not declared in my variable scope. Oh wait, did I, oh, right, right, I saw this. I did this. A single keystroke. All right, compiling sketch. It's gonna flash it over. Boop, 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 boop. There we go, it's writing, very dramatic. And then as soon as it's done, then it gives me a bunch of warnings, but all right, we're done. Cool. All right, so if I press Command-Shift-M, then we have 0, 0, 0. And what this should be telling us is how many packets it's detected, I believe.
Oh, okay.
But in this case, I'm just going to assume that 0 means it's working. because this is the correct response we're looking for. So if you're following along with an old ESP8266, or if you're watching this later, then if you're just getting a bunch of zeros over serial with the baud rate set to 1150-200, then you should be good. And here I am connecting to a couple different pins. Let me double check in my code which ones I'm connecting to. All right, so if I get a deauthentication packet, I'm connected to pin D5. And pin D5 is connected to the green. So deauthentication packets are green, and disassociation packets are connected to D7, which is connected to red. So if we get disassociation packets, we should see red. Let me put that back here. So that's the way that we kind of wired this up. And now that it has been connected, I'm going to plug in. Actually, first, I'm going to go over to my iTerm window. I'm going to... Oh, I've been kicked out of the Hunitor.
And Hunitor is...
So the Hunitor... Oh, wait. H-U-H-N-I-T-O-R. The Hunitor is a program written by our friend Space Hoon, a.k.a. Stefan, that is designed to allow you to easily communicate with the Wi-Fi deauthor. I'm going to plug this in now. We're running the deauthor version 2, which is not as advanced as the V3 that we've covered before, but it's automatically scanning as soon as we run this, and it's going to go through and find all of all of these Wi-Fi networks that it can potentially attack. Now, I am not going to discriminate, and I do not recommend that you run this command, but in this case, I'm going to run the deauth all command. And that is basically going to attack every single device that it has detected during its initial scan. Can I scroll up? Yes, I can. Cool. So here we can see it has found a bunch of different networks, and it can attack all of these. So, all right, what I want to do is I also want to bring up Wireshark. I'm going to start a new capture. I'm going to get rid of this filter. And then let's just watch and see. Right now, we can see that there's no deauthentication packets. We should be all good. I'm going to add the channel just to make sure that I'm not accidentally connected to the 5 gigahertz network. And I am. You sneaky, sneaky wire. Okay.
Yeah, that's what I was alluding to earlier.
I keep getting kicked off. All right, so we're going to switch over to our regular 2.4 gigahertz network.
Yeah.
I'm going to then lock that in by turning on Wireshark as soon as it associates. And okay, I think we're approaching good. All right, so we should be on channel 6, I believe. Let's go ahead and start. All right, yes, we're on channel 6. Cool, and we're using 2.4 gigahertz. So if this is all working, then we should see something light up as soon as we run this attack. Let's go ahead and do it. So I'm going to go to the Hunitor. I'm going to close the bottom one. And I'm also going to make this smaller. Great, okay. Wow, that's maybe too small, but we'll work with it. So I'm going to type attack deauth all. And we've begun the attack. And instantly this lights up. I don't know if you guys can see it, but these lights are now
both are going
fully on. And you can see in Wireshark that we have both types of packets present.
Maybe give them a little more shout. But yeah.
Yeah. So this is just one way that we can detect this much more visually than just using Wireshark. Here, I mean, of course, like I put filters on this, so it's really, really obvious. But to a beginner, knowing that someone's running an attack, it might be, you know, a little bit. Oh,
yeah,
looks like you just got disconnected. Weird.
Oopsies.
But here we can very clearly see, like, okay, someone's running some sort of tool. This is really persistent. It's hitting both, so it's not just some random deauthentication packets. It's also disassociation packets, and that's indicative of a tool that is automated and is spamming just a bunch of these, either to do a denial of service attack, which is actually currently what we're doing, or to otherwise just maybe grab a handshake or something like that.
Yeah.
And that can be really disruptive for a private network. So if you find that you're just unable to connect to your network all of a sudden, you might want to try a device like this and see if you're getting consistently kicked off of a network by packets that are, you know, seemingly legitimate, but actually sent by someone who might have a device like this other little D1 Mini.
Yeah, I think you kind of just mentioned it, but so in what attack scenarios would you encounter deauth?
Lots of them. So first let me stop this attack. Okay, so I stopped the attack. Now I should have accrued, oh, and it turned off. Okay, never mind.
500 cycle, no, wait, no, one's still going.
Okay, there, yeah, so it's turning, Seems like it's still detecting a stray disassociation packet or two. But those, I've found that disassociation packets tend to linger a little bit after, like a full Deauth attack. Like the router will send out some legitimate disassociation packets just out of confusion. But here we can see the green light has turned off. The red light hopefully will turn off soon. But we probably have racked up a pretty high score by adding a certain amount of points every time we do this. So it's going to stay on for a little bit longer just because of the magnitude of the packets. So really what we're also doing here is just displaying very visually the fact that like a lot of packets have been sent. And this can give you just a clue as to whether or not this is a stray packet or if it's something that is, actually being sent persistently by someone.
I think if I were to change the code at all, the one thing I might do is like diminishing returns on the score added. So like if it had detected like multiple Deauth frames recently, instead of adding 500 each time, it would do like half that.
Here we go. It turned off. So in this version of the Deauth, I don't think we have the ability to just send. I don't think we have the ability to just send disassociation. So that's a little bit unfortunate. Because I wanted to show the distinction. But how much time do we have?
Well, we're 35 minutes in.
Okay, so we probably do have time.
Yeah, we have some time.
All right, so let's do some stuff. All right, so let's show off the difference between deauthentication and disassociation. We'll stop this, and then I'm going to go back to GitHub. I'm going to go to I'll just go here. Wi-Fi Deauth. We're gonna go to Stefan's page. Now on the Deauth, there's a couple different branches, and we're gonna go to now V3. All right, so we have V3. We can go to the nightly builds, which is the best way to get the most up-to-date version, which we can grab from right here.
Does he literally build it every night?
No, that's not what a nightly build means, Michael. All right, so ESP8260 says Deauth 2.5. No, 3. Yes. Okay, cool. So this is the latest version. And then here I'm going to unplug for a second our detector, and it'll be fine. It's flash, so it'll just go back to doing its thing as soon as we plug it back in, but I don't want to flash it by accident. All right, so I'm going to exit the Hunitor. I'm going to hopefully, yes. Okay, cool. This is the bash script I'm going to use in order to flash this over. So first I need to get the serial port that this is connected to. So fortunately, there's a couple different commands I can do. I'm lazy, so I'm going to just do the Hunitor again. And we can see that this is the correct serial port. So basically what I'm doing here is I'm flashing the newest firmware over to here. I'm glad I made that full screen because now I have to undo that. And then I'm going to take in Google Chrome. Wait, you want to be full screen too?
You whip around these screens so fast.
All right. It's just problematic, Google Chrome, when you need this much attention. All right. Boom. All right. So now, hopefully, if everything works, we should flash the newest version of the Wi-Fi Deauth over to the microcontroller. So first, it's going to erase it. And I do this because sometimes if you don't, you'll find phantom Wi-Fi networks just around your house.
What?
Like you'll be using the Deauth and it'll be like ESPNet, whatever like the default network is that came pre-programmed into it. So flash it. Oops, it failed. So let's find out what happened. ls/dev/su on macOS. This is the correct serial port. Is that the one we said? Let's check.
Yeah, I don't know. I felt like you just played the shell game and I lost track of what terminal we're in.
Oh, well, I'll make it simple here. Boom. Kill this one. Close. All right, so here, this looks not right. This looks wrong. So let's paste it. This is the one that's right. Let's try that. All right, so we're trying to erase it.
Looks like it's doing some stuff.
Again, this is so phantom ghost networks don't invade.
You just start walking around your house and see.
Okay, so it successfully erased the chip. Now it's gonna. What is this? Now it's going to send me a bunch of nonsense. Ew, what is that? I don't like that at all.
Yeah, that's a lot of gibberish.
Yeah, what happened? Let's try running it again. I may have to manually do this, which would be really lame and boring, but then we'll just use ESP tool with a couple arguments. Wait, no, it hated something. No, it hated something. Okay. It means we have to... Well, let me plug this in to a different port. I feel like that might be the problem, because this cable is janky.
I'm gonna watch your micro USB cables.
Yeah, once they start going
Well,
bad,
particularly for people that may be just starting out, there is a difference between power and data cables.
Oh my god, yes there is. If you accidentally get a
Power cable.
Oh, I know why. This is such a stupid problem. Okay, so the problem is Google Chrome has named this in a way that makes it impossible for it to find.
Thank you, Chrome. So helpful.
Demo build.bin. How about that? Nice and simple. So yeah, see, all this junk is confusing it, and it like ends it right here. I'm pretty sure. Let's try it. It's gonna erase it. It worked the first time too, so I'm like not worried about that. I'm worried about the second step. Still, I will say the easiest way to flash this though, because if you don't do this, then you have to either... Oh, yay, it's uploading. Okay, cool. So it works now. All right, so what this bash script is doing, again, is it is uploading the absolute newest firmware to the microcontroller that's going to allow it to do some stuff that it wasn't able to do before. And by that, I mean it should be able, as soon as it's done doing its
this
thing.
does take a second, doesn't it?
Yeah, it does. Well, yeah. Well, shouldn't take that long, but we'll see. A fatal error occurred. I shouldn't have touched it.
Oh my god.
You shouldn't have moved.
You let it just die?
No, it's depressing if it continues to fail. But basically what this should allow us to do is run deauthentication versus disassociation attacks separately. So that means that we should be able to trigger one versus the other.
Oh, that would be neat.
Yeah. All right. Do not move. Do not breathe. It's being very finicky
Meanwhile,
today.
our cat's in the background trying its darndest to distract me.
What a cutie. All right. So it looks like it worked. And it did work. And I'm relieved.
Woohoo!
Right. Yeah.
It's
So
like 7th time a success.
7th time's the charm. So, all right, we plugged in our detector. We have our new deauther. I'm going to run the Hunator. I'm going to unplug this and plug it. Oh, no, I'll just press the button. Boom. Did that work? No.
When all else fails, jiggle it.
Oh, my God. I will not have you say such things on my show. Okay. All right, so here we go. So we are in the Hunator. We're in the deauther now. I'm typing scan. It's going to run a basic scan. And then in this version, we are going to have to actually manually specify something to attack, but that should be fine. Here we can see it's populating a list of devices that we can attack. So we also get the vendor, which is very handy. Oh yeah, and we can see a list of stations. And there's a MicroPython station that drives me crazy. That's because I forgot to erase the flash.
After all of that, we actually did forget. That's awesome.
Yep. All right, so I'm just going to attack some random station. I don't really care. Oh, wait, no. It's connected. We only have one that's connected, so we're going to do station 2. So if I type help.
Translation. Michael's laptop's going to get deauthed.
Yeah, sure is. All right, so there's a lot more documentation in this version. We can see we can do deauth, ST, like 3 or whatever for the one we want. And then here's where we can select whether we want deauthentication or disassociation. So here, if I type -M and then disassociate, there we go.
Okay.
So it should look like deauth.
Yeah, just to my novice mind, it seems as if like disassociation frames are going to be seen naturally in the wild a lot more frequently, because those are like the ones sent to devices as they're getting their RSSI or the received signal intensity is getting low.
I didn't hear anything you just said. Sorry. Okay, so look, like the red is going off because we're just doing disassociation. So here we can see in the attack, we are not triggering the green lights at all. We're just sending one particular type of packet. So if we were just looking for deauthentication frames, we would still be able to attack things and we would fly under the radar. So by having the ability to detect both types, we can kind of figure out what's going on. And as Michael said, if we're seeing maybe the gentler type of these packets, the disassociation frames, every once in a while, then maybe we're not under attack. Maybe this is just devices leaving the network or something like that. But if we're seeing a whole bunch of both, then that could be different. So let's stop the attack.
Well, I think actually that's a benefit of detecting both, is if you're seeing both simultaneously, I think the odds are highly in favor of it being an attack.
So now let's do the deauth. So I'm actually gonna wait a beat for the red to turn off, and then I'm gonna see if we can get it to trigger the green. Okay, so red's turned off. Now we're gonna run this one, and green instantly turns on.
And red.
Oh, red turned on this one.
Da da da.
Interesting. So let me take a look.
Plot thickens.
Yeah, let me take a look at Wireshark. So if I continue without saving, we can see actually.
Yeah, there's some
deauthentication. So I don't see any yellow. So it seems like, oh no, there's yellow. Never mind. So there's a stray deauthentication packet or two, and we're actually detecting that. So there it goes, and now the red is turned off again. So I saw like maybe two deauthentication frames mixed in amongst all these. And after we do a big attack, we may see a couple just echoing deauthentication packets like from the router or from another device on the network that's like reacting to the attack. So you will sometimes see an echo like that. But here we can see the green light is lit up, and it's basically telling us that, hey, we're seeing a bunch of these on Wireshark. It's orange. We're seeing a bunch of these particular types of packets that we know are disruptive. So if we're seeing a bunch of deauth packets, it's probably an attack because they're used in so many different automated tools, and literally like an 11 or 12-year-old could do it, and they could probably do it quite well. So if you are not a heavy IT person, wow, look at how many there are. If you're not a heavy IT person, this might be just more of an indicator to you that, hey, I really am under attack. Maybe I should investigate the source of this. Like, this might be able to also explain if you have terrible, terrible internet connectivity, even when your signal strength is really strong, that maybe could be the issue if you have someone nearby who's doing deauthentication, or if you have an automated device that's accidentally spamming out these packets.
Yeah, and I think the real value here is the fact that it's an Arduino sketch and it's all open source. We're triggering LEDs, but you could trigger any kind of effect to the. So you could have a buzzer go off. You could connect it to your computer and like have it give you a notification or send you a text or do some other action to let you know.
Fire off some flashbangs in your front yard to scare away the hacker that's trying to steal your internet.
You could just turn on all the sprinklers.
Yeah, there you go. Anytime someone tries to hack your internet, it turns on all the sprinklers at maximum pressure.
Yeah, exactly. Surely it'll get those pesky hackers off your lawn.
So this is a fun hardware project. And again, this is the defensive project. This is something where you can be able to figure out if some of these malicious types of packets are actually flying around your network. And while we didn't go through the necessary steps of targeting this to only one network, it will let you know by proximity because you know these aren't the most powerful antennas on these wireless or on these little microcontrollers. So because
you can
of that,
get better antennas though, right? On some of them,
well, sort of. If
like
you want
external ones.
Okay,
sorry.
It's like yes, you can, but you have to solder a 0 ohm resistor that's the size of a grain of sand. So if you're into that, then yes, you totally can.
Yeah.
But it does require a little bit of like extra work to actually use a directional antenna or a stronger antenna with these little microcontrollers. Although you can, it just takes some very, very, very small soldering. So if you're interested in this type of project, make sure that you check out just the D1 Mini, the ESP8266 in general. It's a really cool microcontroller, and there's tons of projects like this, both offensive and defensive, that are interesting to hackers and IT people alike. And Arduino is a very friendly language to get started in. These also can be programmed in MicroPython, and you could create something very similar by doing the same.
Yeah, and if y'all know of any other projects like this that we should check out, definitely let us know. We love Arduino projects, any kind of microcontroller stuff. We're also open to other GitHub tools and
Yeah,
stuff.
maybe we could make some like sunglasses that like freak out like and start lighting up like as soon as they detect like Deauth packets or something. Or
Yeah,
just,
that would
like,
be pretty cool. Yeah, because I've
jewelry that starts sparkling every time there's an attack going on nearby.
Like on the other side of this, like I've seen like Deauth grenades where you just take like a little lipoly battery or a little coin cell and attach it to a D1 Mini, and it's like a $2 thing that you can throw anywhere and it will immediately Deauth everything around it.
So with a directional antenna, then we could build a fox hunter as well to track down the location of that. And actually, that's another live stream you guys should check out if you are interested.
Yeah.
I believe we did one where we had to figure out which box had a wireless device just by signal strength alone and by hunting it down with Wireshark. So if you're interested in what the next step would be, all right, we've detected that there's a malicious device here. It's broadcasting.
Let's find it.
Let's find it.
Yeah.
So go ahead and check out the Security Forward YouTube channel. That's Security FWD on YouTube, and you'll be able to see that last episode. I think you guys will find it interesting if you like this one. And also you'll be able to watch this and other broadcasts from the past anytime you want. And of course, we have to give a big shout out to Varonis. Thank you very much for making this a thing. And if you're interested in checking out some other Varonis resources, you should check out the AD PowerShell Attack Lab. It's a really interesting way, the AD PowerShell workshop as well as the attack labs. The AD PowerShell workshop is a really good way to learn how to start scripting in Active Directory, and the attack labs are a really good way to learn how modern hackers such as ourselves can break into systems, do all sorts of bad stuff, and still get caught.
Yeah, definitely some good stuff to know, even if you decide hacking isn't for you. Just knowing what people are actually capable of, definitely worth the watch.
Yeah, and at least learning what's easy.
Yeah, exactly. Like, you may think this is a super advanced attack like the Deauth attack, and then you realize, like, literally you could show a 5-year-old how to do this.
Yeah, it's really easy to detect deauthentication attacks, and in most cases it is illegal to do this against a device. It's illegal to attack a device that you don't have permission to. It is always legal to monitor for attacks. That is perfectly fine. So if you want, to just basically see if people are doing sketchy stuff around you, then this will certainly do it.
Awesome.
Cool. And again, a big shout out to Stefan. You can check out him at spacehoon.com or spacehoon.tech.com as well. Because he's the creator of this project, and I think it's really cool. So, all right, thank you guys for joining us. We'll have another stream up soon. Until then, we will see you next time. Bye.